Hi, it's a random bunker slash dumpster item. I found this one in the previous, that monster dumpster thing I found off site, so I'll link in that video at the end and down below if you haven't seen it. And I have no idea what this is, but it looked interesting. And of course, I love these thumb wheel switches, are always fantastic. If you ever see one of those on a bit of kit, make sure you salvage them. They're great for the junk bin for various projects, and it's got some dip switches and Zellweger, never heard of them. It's some sort of receiver test unit, so it's not a receiver. Presumably it transmits to a receiver and tests out receivers. We've got a power switch, FS out, full scale out, I guess, a decabit. What the heck is a decabit? And K22, I have no idea. We can set a level, trimmer, active, a transmit. That's a momentary action switch. So that'll be like it's like transmits a pulse of various frequencies, and there's the list of frequencies on the back here. So anywhere from 167 hertz all the way up to 2 kilohertz there. You just set the dip switch. But the back here is really kind of gives the game away, I think. Anyway, I'm not sure why. It's just got a regular mains power cord. It doesn't have the insulation, so this is like really old school before the regulations that we had to put the insulation on the pins. Anyway, for some reason it goes through a neutral thing, but I think they're just like using that as a grommet entry, but I guess they had some other purpose for it at some stage. But anyway, we've got two different fuses on here, and we've got shrouded 4mm active and RN, which would be return neutral, I'd be guessing. So given that this thing transmits like lowish frequency stuff, and we've got mains in and it looks like mains out with some fuses, I'd say this is designed for injecting those control signals onto control frequencies, control signals, control data, whatever it is, onto mains lines, which actually controls various appliances and stuff like that. Now, this might be very different in other countries. I've got no idea. Please leave it in the comments down below for your particular country and what it's like. But here in Australia, we have what's called off-peak electricity, and which means that particularly for hot water, like the real high energy intensity stuff in everyone's home, if you've got an electric hot water system, then if you have those coming on during the day, that's when you're paying like peak prices for electricity. So what they do is they superimpose a signal onto the 50 hertz mains, none of that 60 hertz rubbish here in Australia, and then that signal activates some detection circuitry inside your fuse box, which then either turns on or off your hot water system during like off-peak times. It might be after midnight, for example, when it's really cheap. So not only does that lower the grid load during peak times, you know, when during the day businesses and everything's going and all that sort of stuff, they've got to like balance the load out. Midnight, not much is happening, so that's when you want to sort of like load up the grid with people's electric hot water during the night time. So they can control that. They can control other things like street lights and other mains type infrastructure. And it's not uncommon for these mains control frequencies to actually upset some particular products, because they've got, you know, little modulated high frequency signals on there, and it can cause, you know, things, lights to flicker and other, you know, things to happen in products if they're not well designed and well filtered and stuff like that. Anyway, that is my guess what this thing does. So we won't turn it on. We'll take it apart and see if my suspicion is correct, because I think that's, unless it's some sort of like, you know, some other custom industrial thing, I think that's what it's going to be doing. I don't know who Enemet is. Anyway, serial number 129. Geez, didn't make many. Anyway, it's in a classic PackTech project case like this. Tons of products are made into... PackTech was like a brand back in the 70s, 80s. 80s, I think. These were popular, these PackTech cases. You can still buy them, so I just call them that. That's just a generic brand. Anyway, and I'm undoing a Phillips screw with a flathead screwdriver. Sue me. Anyway, let's crack it open. Is that... Come on. And we're in like Flynn. Check it out. Wow, that's not old school through-hole stuff, but yeah, all right, let's see what's going on here. Okay, first things first, we've got an EEPROM here. 1991 vintage, so there you go. It's not new. Oh, geez, that's 30 years old now, almost. Crikey. Well, I'll have a look what all that bundled up cable is later, but let's follow the money here. And, okay, so we've got mains input. Let's follow the money. Heat shrunk. That's going over. Oh, check it out. That's going over to a C and K toggle switch. That's the power switch on the front. C and K toggle switch. Those things are 250 volt mains rated, but yeah, it's pretty how you're doing, because if you get solder dags on there, they can get very close to the metal over here. So this front panel, I don't think it's earthed at all, so yeah, not the best. Old school bugger safety, bugger clearance. Anyway, so our mains is switching there. It's it's coming back over here, and it's going to the fuse. Okay, so that is our input mains fuse after the switch, and then it buggers off down to the board down here into a mains tranny here. So that's just a PCB mount, 240 volt primary, and it looks like a couple of wind-ins on the secondary, maybe two AC, low voltage AC secondary wind-ins, but it also jumps over to here. So, right away, this active output goes directly from the mains active over to here. So obviously, if they're injecting anything, it's going to be on the return neutral here, and what's this transformer for? So let's follow the neutral down here. Blue goes down to the board, just got some MOV protection down in there. Diode bridge. Oh, look, there's a bodge wire. That blue wire is coming. Oh, is that some sort of, wow. Oh, hang on. Hang on. Oh, there you go. Why it has to be that long? Have they got something in that? We'll have a look at that later. Let's follow the neutral. So neutral goes down to the board. That'll be going over to the transformer over here as well. The return neutral here doesn't connect over to here. It goes through this other fuse and goes through this transformer here. So yeah, that would be going, I bet you there's a trace going from there. Yeah, I can see it on the board, through the board. Trace from there to there. So that's our supply transformer for all our circuitry. And I believe it'll be going over there as well. So it's going into this transformer. So this is our signal coupling transformer in the neutral line, which goes out here. So that makes sense. So yep, I was right. It is injecting frequencies onto the mains neutral line. And then it looks like we've just got a couple of switching trannies down in there, do we, for the secondary side of that injection transformer, we'll call that. And is that not an EEPROM? That might be a micro, unless that one's a micro, but it doesn't look like it. And nope, that's not a micro, that's a D71054, and that's a programmable timer chippy type thing. So that's got to be our micro under there. All right, so given the vintage, my money is on an EEPROM programmable PIC chip. That's where my money's at. Am I right? It's upside down, all the electrons are going to fall out. No, I was off the money. It is a big M, but it's not microchip. It's a Motorola 68705 EEPROM version. Beautiful. None of that E squared prom rubbish. And like I said, these thumbwheel switches, these are absolutely fantastic things. This one's actually great because it's got a plus minus on there. That's really quite nice. But these things are absolutely gorgeous. So this dials in the command. So obviously, like, it's going to encode like a word, a byte, a word or whatever, onto the mains. And you just dial in the frequency. The trimmer pot here, curiously, goes over to R3 over there, which, so maybe that's like a LM317 regulator or something, and it just adjusts the level or something like that. I don't know. There's not much else in there, just some 74HC series logic, so I'm not even going to bother to take that board out. There's nothing more interesting to see. What's going to be more interesting is if we actually power this thing up and have a look. And then I might do some googly searching for this Decabit K22, because that's obviously some sort of protocol, and Zellweger. Wonder if they're still around. Now this is interesting. All this cable here, there's nothing. These two were all wired together, and if I pull that, yep, just two bare wires in there. So they're not electrically connected. What they're doing, I think, is using this as a capacitor. It's like I don't know why it has to be that long. Maybe like they're increasing the capacitance or something, but they're using that as a capacitor. Why you'd have the ends like tinned like that? Because what it's doing is it's tapping off the bridge rectifier down in there. It's tapping off the negative output of the bridge rectifier. So it's tapping off that, and then it's going into a 74HCT02. I can only presume that that is something to do with like they're detecting when the mains switches. That's their crude method of doing that. Wow, it's pretty how you doing. So anyway, a HCT02 is a quad NOR gate, of course. It's soldered onto the pin there, pin 3. So that's one of the inputs of the first gate there. And so they're, like AC coupling in the mains. I've done that before in my clock mains clock circuit that I built when I was a teenager. I'll maybe have to link in the video. It wasn't quite like that. You do AC couple it, but geez, you know, wires, like it's not like you need some huge voltage isolation or something. Anyway, seems a bit silly buggers, but that's what they decided to do. What? And I forgot to show you that it did have a neon light. So is that... Yep, it's actually, trust me, it's on. It's just really faint. Anyway, we've got on / error, so I don't know why the red thing's flashing, but anyway, it's flashing, and we've got it hooked up on our output here. I've got no load connected, so I've got my EEVblog high voltage probe here because it's the proper way to safely measure mains voltage and other stuff. Anyway, so we are at 704 volts peak to peak, 245 volts AC RMS, because yes, my mains voltage here in the lab and at home as well is right on the high side of the allowable limit. It's like 246, 247 commonly, so yeah, it's getting up there. Even though Australia is supposed to be nominally 230 volts, not 240. Anyway, so we've got a signal there. I've got it set to decabit, and I'm going to pulse the transmit, and I don't see anything pulsing on there, so maybe I need to set the dip switches. And adjusting the level here gets me zippity-doo-dah. Not sure what the deal is. K22, it's still flashing. I presume it's flashing error. And I've connected this FS output to the scope as well, and I'm triggering from that. Presumably it's a 5 volt TTL signal, and I'm still getting nothing. There's just nothing coming out of that, so there is genuinely an error there. Whoa, hang on. I just played around with the code here and it stopped flashing. Look, I was going up 969, 169. Wow, okay. 069, will that, aha, got it, it's a code. Oh, active, there we go. So here we go, I'll just hit active, so it's transmitting, and boop, boop, flash, flishity flash, and then that one's not labeled, and the active turns off. So it transmits for like 5 seconds or something, and then switches off. Oh, 69, winner. Okay, so what I'm gonna do is actually single shot capture this, there we go, and it looks like there's no data encoded on that, so I don't know what that FS output is. Just like a clock. Nope, silly me, I just wasn't thinking fourth dimensionally. Let's do that again. Slower time base, and bingo, we of course have a, there's the data encoded there, so that is 69 encoded in, I presume, decabit protocol, I guess. Okay, I'm just going to repeat that same thing. So that's 69. I'm going to repeat it with the, that's positive 69. I'm going to repeat it with 000. So let's try that again. Single shot capture, trigger. Yeah, that is different to, yep, that's different to what we had before. Yep, so it's encoding that on there. Let me do a higher frequency. Actually, this thing's pretty intelligent. Check it out. If you just like randomly flip the dip switches, it gives you an error. So it knows that, you know, you're either not selected a proper frequency or you haven't selected a proper command on there. So let's go to 2 kilohertz. So I need 1, 3, 4, and 6 on. No, 1, 3, 4, and 6. That should be right. Aha, they're actually grayed out. So I'll go for 1, 2, 4, and 6. 1, 2, 4, and 6. There you go. So it knows. That's brilliant. So let's trigger that again, shall we? Single shot capture. Oh yeah, we've got some higher frequency switching stuff in there. I can see it. But because this is AC coupled, it's a bit how you doing. And there you go, that's just a higher frequency clock. Sure enough, if we measure that frequency of channel 2, 1.59 kilohertz, I've got it set to 1600. Good enough for Australia. Might get more accurate if I go in, but 1.584, there you go. So yeah, that just changes the clock rate. Effectively, it looks like the data rate, like the modulation rate is the same, but the frequency just sets the higher clock rate. That's interesting. And even sticking a 50 watt load on this thing, unfortunately, still doesn't do anything. The yellow is the mains waveform there, and you can see that there's no modulation change at the actual point of switching there. So, you know, we can go in there and there's just nothing. So this thing could be faulty, I suspect. Maybe, you know, the switching tranny or something like that. Switching circuitry could be cactus. So it is supposed to result in like a, you know, 5-10% ripple on your mains there, but obviously nothing's doing there at all, so it's got to be faulty. Anyway, let's go to the Googlies and see if we can investigate this decabit and K22 stuff. As it turns out, there's a Wikipedia page for this. Zellweger off-peak system is a brand name of an electric switching device used to control off-peak electrical loads such as water heaters and probably you know, street lamps and other type stuff. Carrier current, it's called like ripple injection, stuff like that. It goes under various names. But yeah, Zellweger's one of the big players in here, and yeah, they talk about things like amplifiers, stereos can pick up the noise and all that sort of stuff. Ceiling fans can pick up the ripple on there. Telephone lines and all sorts of stuff. There you go. In some parts of the Sydney, 1042 hertz signal usually consists of several bursts of a few seconds off and on for a period of up to 50 seconds on. Coded to affect only selected equipment, of course. There you go. Radioactive risk of one type of Zellweger meter. It contains low risk radioactive material. There you go. Anyway, so that's interesting. And there's a thing for bloody Queenslanders up there, some for Sydney, North Coast and stuff like that. And it looks like there are different brands and things like that. So if we go down here, yeah, technology utilized. Various hardware telegrams are used, K22, Decabit, LG. Oh, Enamet is that company, the sticker we had on the back, but of course it's Zellweger, and yeah, the Zellweger standard, but this Zellweger model, maybe they had their own standard, but they support, it looks like Decabit. I don't know the history of that. Anyway, these are the different companies, Endeavour Energy, Osgrid, and all those sort of stuff. Gemini I've heard of, some of them I haven't heard of, but they, yeah, they have all these different standards. Decabit sounds like one of the major players, but K22's in there too. Then we have this huge document here, which I'll link in down below. Ripple Injection Load Control Systems, Australian Power Quality and Reliability Centre, and from the University of Wollongong. It's very comprehensive. So look, I won't go through the whole thing, whole executive summary and stuff like that. Ripple injection allows access to cheaper off-peak electricity and all that sort of jazz. Mitigation, there's the ripple injection methods for those playing along at home or into your infrastructure, and it's generally applied at the 11 kilovolt transmission level. because there's various step-down voltage phases in the distribution of electricity, and it's typically done at the 11 kilovolts, which will then go through the transformers on the street poles or underground or at ground level, that then will transform that down to 240 volts, which goes to your home and stuff like that. So there's little schematics there. There you go, check it out. So they inject it, coupling capacitors at the substation bus bar there, and then 11 kilovolts, and then it's stepped down, and then it goes into your, that's the 240 volt house. There you go. So, and here's a photo of a typical injection equipment. I can't see much, but it's got injection capacitors and, tuning coils and isolation transformer, compensation caps, absorption coils. Interesting. Sure, you power aficionados are getting pretty moist right about now. And here's the K22 protocol coded pulse algorithm. This is from Zellweger as well. So, looks like they're the go. they own the market. There you go. There's the decabit coded pulse, and that's, I think, what we saw. We just saw like those pulses there on the screen depending on the setting and stuff like that. Unfortunately, we didn't see it ripple in on the mains though, unfortunately. So this is what it's going to look like here, and I actually saw this the other week. I was doing some mains stuff, playing around with it, and I definitely saw that here in the lab. So hopefully I'll be able to capture it again. But obviously that's a time of day thing. I can't even remember when I was testing it. It might have been late at night or something like that. So I might have to, I don't know, come in after 10 p.m. or something and try and capture it. But I did actually see this ripple modulation on my mains signal on the scope the other day. And of course I knew exactly what it was because I've seen it many times before. And it just pops up occasionally. So if your products aren't, so this is what we would have seen. We would have seen like that for how long's a packet or whatever, a second or whatever. We would have actually seen half a second. We would have actually seen that ripple on there for like half a second, then go away, and then that, when you have ripple, that's encoded as a 1, and the lack of ripple is encoded as a 0, or vice versa, however you want to decode it. There you go. And that's 750 hertz on a 50 hertz signal. So that's what it looks like. So by all means, safely monitor your own main signal. You can actually do that with if you want to do it safely. So if you want to do this safely with a Crow, yes, Crow, none of this oscilloscope rubbish. Anyway, because we're in Australia. It's Crow. Give me a break. Anyway, so if you want to do it safely, just use a regular isolation, step down, AC step down transformer, 110 or 240 volts down to, 10 volts AC or something like that. And then you can safely probe with your regular scope, AC signal. And if you sit there long enough and twiddle your thumbs, you'll eventually capture, or you might be able to set up a trigger, of course, because the levels are reasonably high. You should be able to set up a trigger, unless you get other glitches on the mains. Maybe you can set up a capture, a peak capture to get trigger off and single shot capture some of this mains frequency. So an entire signal injection can run for approximately 3 minutes. So that's actually quite significant. So you do stand a good chance of capturing that if you are actually probing the mains and looking for it. Like I said, I was randomly doing some unrelated mains testing the other day. I had my high voltage probe hooked up, and sure enough, there was the ripple. So apparently there is an Australian standard for this for those playing along at home, and it looks like maybe 4 to 6% modulation value, so that's quite substantial. You should definitely be able to see it. And they tell you that receiving relays, that'd be like in your fuse box to decode this, can work down to signals of approximately 2 volts. But signal levels due to amplification of up to 30 volts have been recorded in the field. It was only approximately 5 volts, might be a typical injected thing for 240 volt signal. So there you go, that's fascinating stuff. Shame it didn't work. I could maybe attempt to troubleshoot it and repair and see why it's not actually injecting this stuff. It's coming out of the B and C connector, but yeah, maybe one of the switching trannies has gone or something like that perhaps. But it's fascinating how you can get this rippley stuff on your main. So if you ever see something like that, and it looks a bit how you're doing like this, you know what it is. So let us know in other countries, because I got no idea if this is just, an Aussie thing. I believe it's in New Zealand as well, or whether or not this is common in your country. Do you get this, or what do you call it? Is it, off-peak Ripple, is it Ripple injection? Is it called something else? And what are the typical, who are the players in the market? Because Zellweger seem to own the market here by the looks of things. And let us know in the comments down below. So I hope you enjoyed that video. If you did, please give it a big thumbs up. And as always, you can discuss it down below and over on the EEVblog forum, and subscribe over on EEVblog.tv if you want decentralized instead of this centralized YouTube rubbish. Catch you next time.